Right, so in question 1, we have OA, which is given as 17, that's the radius. AB is 30. Okay, so this is AB is 30. And this perpendicular line will bisect the chord AB. That will be cut in half because this is a right angle passing through the center. So if AB is 30, then AC would be 15. And we can let OC be X. So I'll form an equation. So we'll have X squared plus 15 squared is 17 squared. By rearrangement, X squared will be 17 squared minus 15 squared. So X will be the square root of this number, 17 squared minus 15 squared. And you'll get 8 for your answer here. Okay, so this length here should be 8, which I believe is what most of you got there. Okay, so that answer is 8 for the length OC. Right, so in question 2, we have EG being the length that we need to find. We note that in this question that the radius OG is 13 and FO is 5. And this will, of course, be a right angle here. So if we can find this length here, we'll just need to double it to find the length of EG, okay? So let's find this X here. So we could form an equation. X squared plus 5 squared is 13 squared. So then X squared will be 13 squared minus 5 squared. So X will be the square root of that number, 13 squared minus 5 squared. And when you calculate that, you're going to get 12. So this length here is 12, which is FG, and EF is the same length as that. So this will be 12. So your total length is going to be 24. Right, so in question 3, we are given JK, which is 14 units. That's this length here. And we want to find OJ. So OJ being this length here. So what we know that if JK is 14, this is the center, that's the right angle. So JK is being bisected by this line here. So these will be equal lengths, which means that to this point here, this will be 7 units. And let's call JO or OJX. So we'll do Pythagoras again on this triangle. So we'll have 7 squared plus 7 squared is equal to X squared. Okay, so X will be the square root of the sum of those two numbers. And when you do that, you'll get 7 root 2. So when you round it off, that would be 9.9 for the length of OJ. I think in general terms, it's better to leave it in the third form because this is the exact form and this is an approximation. So I think in many questions, it's worthwhile leaving it in the exact form. This is an approximation. So, okay, in question 4, we have DE, which is 16. This is a chord, 16 units long. So this chord is going to be bisected by this line here. We have a right angle, we have a center. So this line is being cut in half, it's being bisected. So if D is 16, this side will be 8, won't it? And we want to find OD, so let's call ODX, that's the radius. So let's form an equation using Pythagoras' theorem. So we'll have 8 squared plus 6 squared equals X squared. So that one's easy to do in our head. So X squared is 64 plus 36, which is 100. So x will be the square root of 100. So x will be 10. So the length of OD will be 10 units. So in question 5, we have point E being the center of a circle. TU is perpendicular to RS. So TU is the diameter, RS is this length here, which makes sense, it's perpendicular. VS is given as 4. So this length here is 4, isn't it? Okay, that's 4. And because your line is being bisected, this length here is also 4. So RB is 4 because it's the same as VS. Part 2, if TU is 10, which makes sense, let's clear that out. TU is 10, this line, which makes sense because the radius is 5, isn't it? Which means that from E to U, that's also 5, but also E to S is 5 because that's equal to this radius here. And we worked out that this was 4. And we want to find EV, this length here. So EV, let's call that X. So we formed a right angle triangle here. And we can apply a Pythagoras' theorem to find X. So we'll have X squared plus 4 squared, the 2 legs, equals the hypotenuse squared. So X squared will be 5 squared minus 4 squared. So X squared is 25 minus 16, which will give you 9. So X will be 3. Okay. So that's your typical Pythagorean triad, actually. So this length is 3 for EV. That's a typical triangle, a 3, 4, 5 triangle. So 3, 4, 5. So this is a triangle that is probably worthwhile remembering. 3, 4, 5 triangle. Right, so in this question, we have 2 triangles in 2 different places and 2 chords. So you've got UV, which is 6. So the first thing we can do is find Y. So this chord is UV, which is 6, and it's bisected. So this length here, OV, is going to be 3. This leg here to the center is 4. So we can apply Pythagoras' theorem to find Y. So in this case, we're going to have 4 squared plus 3 squared is Y squared. So it's 16 plus 9, Y squared. Y squared is 25. So Y will be 5. Okay, straightforward. So this length is 5. So if this length is 5, it also means that QT is also 5 because that's a radius line. They're both radii, aren't they? So that's 5. This length is 3. And because RT is being bisected by QS, this length here is also 3. And by our Pythagorean triangle, 3, 4, 5, we can use that to find this length, which is 4. So it's exactly the same as that triangle, 3, 4, 5. So X will be 4. So actually, these 2 triangles are congruent triangles. They're just in different positions. And the chords are the same length. So everything makes sense there.